Hello YouTube. I've recently bought a new tool which I've not seen any reviews for on anywhere really. It's a KAUSU impact driver from AliExpress. It cost about £35. So I'm just going to test its torque. I'm going to be driving these 180 millimeter bolts. I think they're M13. They've got a 19 millimeter hex. So I'm not 100% sure of the size now, but I'll be measuring the torque after I've driven them in, how much it takes to go past where I put them in, to get a rough idea of how much torque it can provide. I'll be going through each step, replacing the battery for a slightly better one, until we get to a parallel battery connector to see if it can just soak up all the amps. And so let's see how far we can get in. So it's in the highest mode and it's in metal mode. The features of this we'll get into another time, but let's just see. We'll leave a bit of a gap around there, should be safe. And let's go, see how far I can get in. Okay, so that cut out by itself. Right, okay, so the end of that was interrupted by a phone call, but the tool did cut off, probably from the battery side. So what we're going to do is get the digital torque meter, and we're going to set it to peak. Just make sure it's reset first. Track. Peak. Okay, right. So let's see how much torque that was. Okay, so it took 17.3 Newton meters to get that moving again. So this battery's not particularly powerful, or the tool's not particularly powerful. That's 17.3. So we'll move on to a bigger battery now. Okay, so we're going up to supposedly a 4 amp hour now, see if that gets it any further. Okay, 3, 2, 1. Still moving. Ooh. So I'm just going to pause it there because it's just about to be driven all the way in, and we'll see how much torque that takes. Now it has split the wood, which is obviously going to negatively affect how much resistance there is. So that's okay. That's so 33 Newton meters to get that to move again with that battery. And I'll be honest, I was expecting it to not be able to drive in the bolt. Right, because this wood wasn't strong enough to do the testing that I wanted to, I'm just going to do a speed test with this impact by Continental. It's quite small. It's got no rating, but I think it was sold as 500 Newton meters. I don't believe that, but we're just going to drive it in and see how fast it can go. that's actually stopped moving. This one drove it all the way in. So I'm just going to take a torque reading of this one. Reset. So that's set to 0. And we're going to see how much force it takes for this to get going again. (18.7 Newton meters). So this one's like not very good at all, and it was definitely in full power. So I'm surprised by that the smaller one. This so this KAUSU, really good. This Continental was about the same price actually. So the fact that an impact driver can outcompete this thing, which £35, £30, it comes in a kit with a drill. Quite surprised by that. So we're going to move on to GSAM, and this one's like a big boy. This is a fresh battery, by the way. And I'll use a fresh bolt. And remember, at this point, this is a speed test because the wood's just not not strong enough to properly test these tools. Just check this is in the right. Yeah, so that's in full power. I'm going to go doing that around there, and let's try it again. Okay, so that's not all the way in yet. Let's go again. And that is definitely in full power. Okay, that's in. That's driven it into the wood now. So we're just going to take a reading of that now. I think maybe just my idea of testing the torque after it's been driven in doesn't really work, because obviously this is like an impact and this is like a static force. So it's okay. So this is now starting to feel more like it. Okay. So, okay. So the peak force to get that going again was 57.5. So again, I don't know what these results mean, but I do know that this little tool drove in one of these bolts all the way with a cheap 4 amp hour battery. So if you're in the market for an impact driver, for like a hex shank impact driver, this KAUSU from AliExpress, I think it's really good value for money. I think it's 11 centimeters, 110 mil in width, which is only a centimeter bigger than DeWalt's atomic line. So I think it's pretty damn good, and the lights on the front, so you can actually see what you're doing. It's easily serviceable. The downside to this tool is it's got 4 different power modes and 4 different like materials. So the materials are timber, thin metal, thick metal, and auto stop. Obviously auto stop isn't a material, but I find that too finicky. There's no need for it to be that complicated because the throttle control is quite good. So there's no need for those separate settings other than the power limit. And also these buttons are really hard to press. They've saved money. I've taken this apart, and usually there's a membrane and then a separate circuit board underneath that membrane, so you can like press it. but this membrane is stuck directly to the circuit board, so it doesn't actually have enough room to be pressed easily. But anyway, that's my review of the KAUSU. It didn't go to plan at all, because this wood's just odd. And I'm quite disappointed with this. I expected it to be much, much faster, but it isn't really. One thing we haven't tried is if giving it as many amps it can possibly have. So these are two 6 amp hour batteries into a parallel connection, and we're just going to see if we can finish off driving this one faster than it did just by eye and feel, like not actually timing it. So that's on, and let's go. Yeah, so I'd say it's quicker. So this this tool loves having extra amps on tap. So you get the best quality battery you can for it, and it should be able to, you know, use that power. I'm not sure how many amps this type of setup can provide, but I have got a tool, a chainsaw, that has a voltmeter on it, or a voltmeter, a battery percentage, and when the tool's under load, you can really see like it fluctuate when you're using a single battery or a smaller battery, and when you're using like a battery in parallel like this, the voltage drop, and therefore the battery percentage level doesn't fluctuate as much under load. And so with a single one of these batteries under load, it like shows like, you know, 60-70% in remaining, because the voltage drop is so high. Whereas with both of them, it's like, you know, 95%. So it's a drastic difference. Plus, it's just cool having that on the end of a tool.